Hello YouTube students, my name is Vincent and today I want to take a look at trigonometric equations. In particular, I want to look at the question, find tangent theta if cosine theta equals 8 over 17 and sine theta is less than 0. Now for this problem I have a table of the basic trigonometric functions and their definitions, as well as the SOHCAHTOA mnemonic, which is just a really useful way to remember these definitions. And also we have the Pythagorean theorem listed right here. We're going to need all of this information to solve this problem. But before we begin looking at this question, another piece of useful information that we're going to need is the fact that all of the trigonometric functions are positive in the first quadrant. Sine is positive in the second quadrant. Tangent is positive in the third quadrant. And finally, we have that cosine is positive in the fourth quadrant. Now to remember this, we have this ASTC. Some teachers will show all students take calculus. If you have a goofy teacher, they may show you all students take crack. I don't know, I personally like the second one, even though the idea of all the students doing that is pretty terrifying. So, to begin this problem, another thing I want to consider is that in the first quadrant, when we have a pair of points, x, y, we have that x is greater than 0, and we have that y is greater than 0. But in the second quadrant, we have x is less than 0, because we go to the left x, and we have that y is greater than 0, because we go to the left, and then we go straight up. So now we have in the third quadrant, x is less than 0, and y is less than 0. And finally, in the fourth quadrant, we have that x is greater than 0, and y is less than 0. This is going to help determine how to make the sides of our right triangle involved in solving this problem. But now that we have this information, let's go ahead and begin looking at the question. We have find tangent theta if cosine theta equals a positive 8 over 17. Well, the fact that cosine is positive automatically eliminates quadrant 2 and quadrant 3, because sine and tangent are positive in the second and third quadrants respectively. So there's no way that cosine could be positive in this quadrant. So now this leaves us with the first and fourth quadrant. So to determine which of these quadrants we're going to be in, we use the fact that they told us that sine theta is less than 0. Well, if sine theta is less than 0, what that does is it eliminates the first quadrant, because all of the trigonometric functions are positive in the first quadrant. So sine theta is out of here. So now that we know our theta is in the fourth quadrant, we could go ahead and sketch a right triangle using theta as our reference angle. So we look at theta, and remember the reference angle for theta is always the distance back to the x-axis. So using this radius that we're drawing out here, we consider theta to be the angle bringing us back to the x-axis. We wouldn't draw theta towards the y-axis. So now, one thing we need to find tangent theta. But notice that only cosine is positive in the fourth quadrant. So when we do find our answer, we should get a negative number. This is just something that's helpful in the event that we get a positive number. So now, we're looking at our reference angle theta, and they told us that cosine theta is equal to 8 over 17. But recall that cosine theta is equal to the adjacent side divided by the hypotenuse. So on this right triangle that we have that the adjacent side of this right triangle is equal to 8, and we have the hypotenuse is equal to 17. Since they're telling us that cosine theta is equal to 8 over 17. So we look at the ratio of the adjacent side over the hypotenuse, and we fill in 8 and 17. But now what we need to do is we need to find the missing side of this right triangle, keeping in mind that whatever this length is, so far all we have is the x-coordinate as 8. But we know, since we're in the fourth quadrant, that our y-coordinate is going to be less than 0 because we're going down this way along the down along this way on the y-axis. So now we look at this right triangle and we have, if you know this off the top of your head, this is a Pythagorean triple. We could just say that this is 15. But let's go ahead and investigate how we would get that if we didn't. We use the Pythagorean theorem and we would have 8 squared, and we'll call this missing leg b squared. 8 squared plus b squared is equal to the hypotenuse 17 squared, which gives us 64 plus b squared is equal to 289. So now we subtract 64 from both sides, and we have 225 is equal to b squared. I'll write this over here. We have b squared is equal to 225. So now to solve for b, what we need to do is take the square root of both sides, and this tells us, this sign means implies, this tells us that b is equal to 15. So the missing side of this triangle is 15, but keep in mind, this missing leg is our y coordinate, because this is going to be the vertical distance, and we're going down, so we're going not a positive 15, we're going a negative 15. So that tells us that this point that we're winding up at is the point 8, negative 15. So now we're almost done. All we need to do now is take a look at what is tangent of theta. Well, keep in mind, tangent of theta is the opposite side divided by the adjacent side. And now we have opposite of theta is equal to minus 15. And now adjacent to theta is equal to a positive 8. So we have that tangent of theta is equal to minus 15 over 8. And now, as I said before, it's a good thing that our answer came out to be a negative value, because we're in the fourth quadrant and only cosine is positive in the fourth quadrant. So we know that our answer is going to check out. Okay, well, this is going to conclude the problem as well as this video, and I hope that it was helpful. Thank you for watching.